Geography 596B talks for the Fall 2 semester. My name is Doug Miller, and I'll be your host today. We have three speakers today, Thomas Osen, Jason Biagio, and Jeff Kling. They will each have 20 minutes to share what they have been working on with their 596B, their capstone project. And we will let Thomas get started here. T.O. comes to us from North Dakota. I would ask that as you come up with questions during the talk, please type those into the chat area, and we will collect those. And at the end of the presentation, we'll have a brief period of question and answers for each of our speakers. So T.O., if you want to get started, we can commence.
Okay, thank you, Professor Miller. You guys can see my screen here, the story map?
Yes.
Yep.
All right, cool. All right, so good morning and good afternoon for some of you. My name is Thomas Osen, as Professor Miller said. This is my presentation on drone map building an oil field database. About 2 years ago, as I started this master's project or program, I often wondered what this day would feel like, and I thought I might be in some big conference somewhere, and I never dreamed I would be presenting here in sweatpants. So I'm pretty happy that I could do this from home and not in front of about 200 people. So, but anyway, this is for Geog 596B, Penn State University. My advisor was Karen Schuckman, and this is fall semester 2. This is the part 2 of my presentations on drone map to finish my master's project. Just a little about me. I'm a professional land surveyor and consultant in the oil field. I've worked in both North Dakota and Montana. My company, Fourth Dimension Surveying and Consulting, focuses primarily on 3D mapping, multispectral imagery, LiDAR modeling, various things like that. I've worked in the oil and gas industry as a consultant and land surveyor for the past 10 years. I have an incredible fiance who you can see here in this photo. This is from our engagement photos we took about a month ago. She's been incredibly supportive as I've grown my small business and gone through this master's program, and we reside here in Williston, North Dakota. She's originally from Canada. She's a nurse down here. We reside here in North Dakota in Williston with our 2 dogs. So a little bit about the project region. Basically, we work primarily near Williston and Washington City, shown here on the map in blue and orange dots respectively. The blue squares that you see are project areas that we've flown either once or multiple times, sometimes in various stages of the project. We would fly multiple sites depending on the stages where it was built. This total area is roughly 3,500 square miles. So that being said, this produces a major challenge for our clients, just logistically trying to get to all their sites. It also produces a major constraint on us because as we fly these sites, we produce a tremendous amount of data. Drone data is some of the most incredible and visually robust data that we can collect and work within the realm of GIS and surveying. It allows us to make informed decisions and use highly accurate and scaled survey grade 3D models, 2D orthomosaics, and a data abundant point cloud. However, this vast amount of data comes not only at a monetary price, but it also is limited by its giant size. For most people, an average work computer cannot handle the drone data that we produce, nor can we share the data with ease. On average, for every gigabyte of raw data that we collect, 4 times that is generated in deliverables. So for example, this high resolution 2D orthomosaic will range anywhere from 1 gigabyte to 6 gigabytes, just depending on the size of the area that we map. So definitely it's not something you can email. The 3D point clouds and meshes range in size from anywhere from 500 megabytes all the way up to 4 gigabytes. And this detailed imagery and 3D models is great and highly sought after by my clients. After all, it is 1 inch per pixel resolution. Just as a comparison, when you go on Google Earth, that's about 6 inches, even as low resolution as 12-inch resolution per pixel. This also results in a major challenge is how do we share this data? Is often my clients, their headquarters are in Texas, Colorado, various parts of North Dakota, and it's not easy to share this. One of my prominent clients has invested significant money for us to collect this drone data over the past 4 years on these 100 well sites. Although the data was used for its intended purpose by utilizing our advanced computers and processing software through Pix4D, the client is unable to use the data without us hiring us back to come and extract it for them, store it for them, things of that nature. And one valuable lesson I've learned in my work and also going to school here at Penn State is that the data is not easily accessible, usable, and at their fingertips. It's often not utilized at all once it's put into storage. So to solve the challenge, I determined we needed a software that was not only able to process the drone imagery, but also could pipeline it directly to the enterprise portal or platform that our clients often have. I had already been using Pix4D to process this imagery. And as a result, I was able to find DroneMap, which is a team effort by Esri and Pix4D to join forces, basically use Pix4D's algorithms to process the data, and then use the Esri interface that many people are used to and easily can navigate through. By processing the drone imagery through DroneMap, the resulting products and even original raw data can be uploaded and stored into the client's enterprise portal, and anyone authorized inside the company can then access this data and do further analytics. If they need advanced analytics, they can simply download it with their in-house GIS softwares and analyze it there. So what is DroneMap? It's basically just an advanced software that processes drone imagery. Excuse me. And the biggest thing that this allows us to do by putting it on the portal is it allows us to eliminate the need for everybody to have an advanced computer, which is a major cost savings. So what is Enterprise Portal? It's basically the back end of this. It's a component of ArcGIS Enterprise that allows you to share maps, scenes, apps, and other geographic information with other people in your organization. It helps you create web maps, scenes, and basically to store all this data in a secure format. And it uses the power of a server so that your employees don't have to have that heavy lifting computer. Just to give you an idea of the computer I use DroneMap with, costs about $4,500 to comprise all the CPU, RAM, everything, processing graphics cards you need to make the software work. So by being able to put this on the portal and allow them to look at gigabyte sized information and be able to look at it on their phone or on a desktop and make a customizable map is huge. So again, some of the DroneMap features, it's Pix4D software. You can batch process. It can be used offline. So if you're in a remote location, that's very nice. You can do inspections of the imagery. You get a full array of 2D and 3D products like we've mentioned before. You can even do multispectral and get NDVI and various indices that way. And everything can be shared then to that portal. So to give you an idea of the process, we can use a DJI M300, which is our latest drone that we're using right now with a multispectral Altum sensor. You can also use drones such as the Eevee, which is a fixed wing platform. So this is my business partner collecting an aerial target. Aerial targets are very simple. They're just simply a paint dot that we shoot with a GPS on the ground. They're just made of a 4-foot stake that we've painted orange that you can then see in the digital imagery. We shoot this with a GPS, have a coordinate, and then we can basically tie the model to this. We put about anywhere from 3 to 5 of these scattered across the site, and this allows us to pin that model to the ground to a specific coordinate system. And then if we need to do any type of staking off of it, we can make a design and go back and stake it. So I wanted to give you a quick view of the interface of DroneMap. Very basic, very much looks like ArcGIS Pro. As I mentioned before, you can do batch processing. Basically, you can set up anywhere from 1, 2, 3, 4, all the way up to 50 projects. And once you have those set up, you basically collect them into a master file and then hit start. And you can just basically let your computer cook for the next 2 or 3 days as it processes drone imagery and all the 3D models. For this project, I used roughly, it took me about 15 to 20 days to batch process everything, get everything together, and make the models. And then, like I said, once the data is processed, it can then go to its final step, which is onto your client's portal. What's nice about story maps is that we can explore some of the custom maps I made. If you had a image viewer, you could have the raw data would show up, such as the raw imagery. You can look at various contours, and you can see the raster DSM in the background. You can see the height of the photos, which are the blue dots, and you can pan around in the model. Another variation and handy thing about the portal is you can make a custom web map that would show you a raster DSM or DTM, in addition to a point cloud that is all in 3D. In addition, you can do a big global map that shows you 2D orthomosaics. And you can simply go to wherever those locations are that you want to see and see the various high resolution imagery. So just like Google Earth, you can pan around and go and see these various models, and you're not without the need of having to go there necessarily. This saves a lot of time and effort on our clients when they can just simply have a picture. As I said, you can do multispectral imagery. You can do all sorts of indices such as red edge, green normalized difference, vegetation index, modified soil, and many more. And this is my favorite, is the 3D meshes. Is it not going to run? It's not going to run for me. Basically, you can pan around in these maps. If you click on the link in here, you can go and pan around, look at all these 3D models and in their actual space in the globe. Here's kind of a 2D or a 3D view of it, or screenshot. Basically, you can perform area and distance measurements, heights, various things like that. And then you can create custom maps. Let's say you just wanted these 2 areas in blue on the left. You can make those and just make a customizable map that you can then share with your team to do analytics on. You can also track changes with Drone Map and the ArcGIS portal. As you can see in this image down here in the bottom right is a bare pasture. And then up on the left is the same area that is covered with a new well site. And then from that, we were able to design the drill rig spacing, how that's going to sit out, and then how you're going to logistically put a central tank battery on the site at the same time. So for logistics planning, this is critical. Some of the limitations that I came into, the major analytics, the surface modeling, things that you want to do with a point cloud, that's all going to have to be done in Drone to Map itself with a license, or it's going to have to be downloaded and used in ArcGIS Desktop or Arc Pro. You need a very powerful computer to do so. ArcGIS software knowledge is extremely helpful. There's a lot of workarounds that you have to use when you run into bugs. I ran into one bug where it wouldn't let me upload a DSM or DTM up to the portal. It did on about half of my projects, but not the other. I've worked with Esri for about the last month trying to figure out why, and we have not been able to find a solution. So there are some workarounds you can do with ArcGIS Pro. Like I said, limited analytics on the platform itself for the portal. You need an image server if you want to look at the raw imagery and data like that and store it. And in the scene viewer itself, if you load up the DSM or DTM, it does not convert stuff on the fly. It takes the projects that I was working in feet and thinks they're meters and translates it, those elevations into these large towers that you can see here on the left. As I was going through DroneMap and doing research and working with Esri, it came to light that their site scan platform, which is their complete online portal, was their more sought after platform that they're moving to. It runs with Pix4D. It's exactly like DroneMap, except it runs on a cloud. So you don't need necessarily even a heavy lifting computer, just a good internet connection to get your raw imagery, and then it'll process. And due to the short time frame when I did find out about this, and there not being a student version, I was not able to test out SiteScan. But like I said, the results would have been the same using DroneMap versus SiteScan. So a couple previous questions and solutions. In my last presentation, it was brought up to my attention about the new datums that are coming out in 2022. Basically, we're moving away from NAD 83 and NAVD 88. And removing and replacing these, the National Geodetic Survey is replacing them with what they call a dynamic terrestrial reference frame. This means all the data that we're processing now under the current datums will change, and we'll have to reprocess some of this data if it needs to be used in the future. There are going to be some software conversions that will allow us to convert the models to the new datums, but it's not necessarily guaranteed the accuracies of that. And so it could be very cost prohibitive to go back through a datum or a database like this and get everything up to date. But right now, the best practice is to keep moving on with what we have. The other thing was, what would we do with the process and report or the quality control aerial targets? That can all be uploaded to the portal for your team to use and reprocess the data at a later time and see how good the data is in itself. Here's an example of where the ground control points are shown in these green stars around a site. You can see the table of the uploaded aerial targets. So if a team wants to go back and reprocess this in the same data coordinate system, they can. And here's an example of the quality control report that's uploaded onto the portal. You can see that everything has green check marks. The root mean square error is under 0.03 of a foot. And here's a continuation of that report showing how good the aerial control is. Everything was less than 1 inch in quality. That's giving you some of the best data in the planet. So just a summary of DroneMap. You're able to harness the power of Pix4D and Esri's array of GIS products, store data in multiple third-party drone data companies that are all compiling this for your single oil company. That all can be compiled into one spot, so you can get it from anybody. And if those companies move on, you go with another company, you can then have your data and you don't lose it. Multiple groups can utilize the data. The data is stored safely and securely on the portal. You can access it at any time. This increases productivity, improves efficiencies, and saves money. And then you can utilize the data over and over. You can track changes and easily share the data with your team and anybody inside or outside your organization that you want to. I want to give a special thanks to Oasis Petroleum, specifically Damon Jorgensen, for giving me authorization to use this data and process it and share it with you. Sarah Bossard is their in-house GIS tech. She helped me tremendously with these story maps and just DroneMap itself and troubleshooting a lot of it. Also, Brian Connolly of Esri helped me in getting this project underway. And then Professor Schuckman and Douglas Miller for getting me the student version of this. And with that, this is a picture from the first day of school at Penn State. And with that, I'll take your questions and feedback.
Very nice, T.O. Audience, do we have questions for T.O.? You may type them into the chat area, and we will go through them. I guess I'd start with a question, T.O. The new datum that's coming out, the dynamic datum that MGIS is instantiating. It sounds like this could be a massive data conversion effort, and I'm wondering, there's always this period of when do you stop using the old one, when do you begin to use the new one? do you think do you think, in particular, in thinking about drone applications now, and the work that you've done here, do you think this is going to end up being a major issue when trying to work with uh, change data or looking at change over time?
It definitely older data. I think we have like up in North Dakota, we often don't switch back or switch to newer datums that quickly. It sounds like the NAVD 88 and all that is going away completely. They're not even going to allow you to use it. So yeah, there's going to be some major issues trying to convert all that. And it's going to be costly if you're trying to go back and use old data. Hopefully they'll allow you to work in it under those old datums somehow. But I'm hoping that some of the conversion software will get that stuff converted rather easily, and it'll just be able to convert stuff almost on the fly. It'll be very interesting because this is one of the major changes to GPS surveying and drones and all of this, and it's happening right in the middle of one of the greatest technological revolutions of our time. So it'll be very interesting to see how that's going to affect everything. It could be a disaster for some. As Reese says, you're going to have to be extremely knowledgeable in it in order to make some of the conversions and make sure stuff's getting converted correctly.
Interesting. Ryan asks, did you say that you acquired your own computer to host ArcGIS Enterprise and Portal? Had you contemplated using cloud services for that, like Amazon?
I did not. I actually used the Penn State portal for the example portal for this project. I used a student version of Dronomap and then uploaded everything to the Penn State portal to then demonstrate. I did not think about using anything like Amazon's cloud-based portal or anything like that.
Alexandra asks, did you consider other 3D mapping drone technology other than drone to map?
There was obviously SiteScan came up. There's Drone Deploy. There's a few others that companies use, but Pix4D seems to be at the prevalent front end of that. And the ability to merge with Esri's portal was the main driver, because most of my clients that are of large size in the oil field have some type of GIS program that uses portal already. So it's just a matter of formatting it to be big enough to hold drone data.
And do we have any other questions? If not, let's remotely give Tio a hand for his talk. Excellent work, Tio. And we'll move to our next presenter, Jason Biagio. Jason has been working on how to forecast hazelnut production using stochastic and machine learning approaches with Python and a Jupyter Notebook. And Jason, I'll let you share your screen and get started when you're ready.
Okay, thank you. I'm trying to figure out how to get my screen shared. Let's see here.
Thomas, you might need to stop sharing first. Yeah, there we go.
Okay, share screen. We're almost there. All right, do you see my screen?
Yes.
Very good, thank you. And Thomas, great presentation. Yeah, as Doug had said, I'm trying to forecast hazelnut production using traditional stochastic methods and machine learning approaches. My advisor was Dr. Richard Marini, and here's my presentation. We go to the next slide here. Okay, why is it not?
Maybe try using the arrows.
There we go. Okay, so a brief overview of my presentation, of introduction, objectives, the background information, my specific research methods, results, and discussion conclusion. So, introduction. So why forecast hazelnut production? Well, forecasting in agriculture is very important, as it allows us to plan for farming resources and harvest time logistics. So about hazelnuts. It's known the world over as the filbert. It's a unique in the nut world in the sense that it's a self-incompatible plant that has both male and female flowers, and they bloom at different times. And it's wind pollinated during the winter time, which is again pretty unique. I'm primarily concerned with pistachios here in the Central Valley, so hearing that something pollinates the winter was different. So it's important in the world as it ranks 5th in nut production behind the pistachio. As I suggested earlier, it's wind pollinated in the wintertime, and it's primarily confined to the Willamette Valley in Oregon, but that is changing. So here's the Willamette Valley region in Northwest Oregon. So 99% of North American hazelnut production occurs within this valley, and that's primarily due to a blight called Eastern filbert blight that affects other hazelnuts in North America, although this is changing with recent cultivars being developed with a joint effort from Oregon State and Rutgers to help fight or to become more resistant to Eastern filbert blight. So objectives, what are the objectives? I had two to try and stay focused and simplify my efforts. And it was one to endeavor to perform forecasting using a variety of approaches. But a secondary was to perform these predictions using open source software and to evaluate the suitability of that. Penn State introduced me to Python programming language, and thankfully, it's been the go-to tool in my GIS toolbox. And so I was hoping to leverage some of that with this study, and was quite surprised at how well it performed. So we'll get into that in a moment. So background. So there's a lot of terms that I would like to go over, but rather than become a survey of statistical methods, I just chose popular and traditional approaches common to time series analysis and forecasting. In simple terms, regression seeks to find the relationship between a dependent variable and one or more independent variables. In the case of this particular study, the dependent variable is hazelnut production in the form of yield in tons per acre planted per year. So, and the independent variable, of course, would be time. So again, without getting into great mathematical detail, these are some of the traditional methods that I leveraged. I also wanted to look at forecasting using more modern machine learning approaches. And again, while I could spend an entire career studying and developing and evaluating machine learning approaches, I chose 3 that were familiar to me and that are quite performant. So to begin, a long short-term memory network is a type of recurrent neural network that allows previous predicted outputs to become future inputs, and it's capable of learning long-term dependencies over time. And again, you could spend an entire career on just that one neural network, but I also tried to look at other popular approaches. So XGBoost is actually a very performant machine learning approach, and they have libraries in all of the popular programming languages. So if Python isn't your cup of tea, I guarantee that you could use XGBoost in R or C#, Java. It's fantastic, and it's very, very performant. It aims to leverage weak estimators in an entire group and to optimize outputs. It's kind of like a decision tree network, but on steroids. Teapot tool is unique in that it uses genetic programming, so it goes through an iterative approach to find the optimal method to perform forecasting, and it's automated. So that one was actually very interesting, and it performed very, very well too, you'll see. So in terms of judging how well the different methods uh, performed, I needed to have some type of performance metric. So I used, for all the predictive methods, they were evaluated using these common statistical accuracy metrics. The forecast bias was new to me when I started, and it's simple to calculate, and it gives an indicator of over or underestimating a particular prediction. If a model has a negative bias, it's generally over forecast. That is, it will estimate values higher than the actual. The inverse is true. If a positive bias from a model, it means that those predictions will generally be under that of the actual value. So weakly positive or negative biases indicate a predictive model that is generally accurate and close to actual values. Research methods. So the novelty of this particular study, and by extension Python and Jupyter Notebooks, is the ability to perform all aspects of the project within a single self-contained web-based notebook. The notebook lends itself well to iterative programming and can serve as a template for future study. So as I walk through the methodology, it starts by using the Miniconda package manager for Python. I created a development environment, and the environment includes all the libraries and imports required for the use of the project. And I'd be happy to provide the environment variables as well as the accompanying notebook upon request at the conclusion of my presentation. The next step was to import data from the notebook, then perform forecasting. And I deliberately ordered the methods to go from simplest to more complex just to see how they would perform. And then after the predictions were made, I compiled the outputs and error metrics, and then for evaluation of overall performance. So the data was from two sources, and this was kind of an on-the-fly adjustment that Dr. Marini and I made. Originally, the scope of my project was to develop a phenologic model, which would predict different developmental stages, like bloom date, nut formation, and that type of thing. But the phenologic model requires a vast amount of data, and it just wasn't available. I tried to work with the hazelnut industry in Oregon, and they did not have the requisite data available. So I fell back onto freely available resources, and I was able to obtain production data from the Department of Agriculture from 1927 to 2008. The hazelnut industry also provided me data from 2009 to 2018, and I use that as truth. This is a quick slide of the Jupyter Notebook where the data was inputted and then just evaluated real quick. You can kind of see that the hazelnut production data that was available to me was the bearing acreage, yield per acre in tons, the utilized production, and then so on and so forth. I chose to use the yield per acre in tons as the predicted output because with varying planted acres per year, it could still be used to forward forecast. The graph is a ordinary least squares plot of the hazelnut production data. One of the things that, or a couple items of note, is that you can see the up-down kind of oscillation from year in, year out with this data. And that has to do with what's called the alternate bearing cycle of plants, where there's an on year and an off year. And this oscillation occurs when plants will produce greater than average one year and less than average the following year, is a kind of a recovery year. One of the things that is also interesting is post 1990 of the production data, you start to see it become very, very volatile. And I think that has to do with changes in farming practices, wherein they're trying to supercharge the on year, get a higher production, and therefore the delta between the on and off is increased. The weather data I use is exogenic variables. And so some of the predictive models can leverage these external data points as additional inputs for a more balanced prediction model. That's the list of the weather data that I also leveraged. After the data was obtained and the different models were formatted in the notebook, I performed the forecasts. So how did they perform? Well, here's a table of the outputs, and you can see on the top row, that's the actual yield per acre for the hazelnuts, so 2009 and following. And then you can see the predictive methods on the left-hand side. Obviously, it's a big table, not very descriptive, but I just want to show it to you. So I plotted the data. I know the graph is a bit busy, but bear with me as I decompose the results. First, note the blue line. This is the actual yield for the hazelnuts. And each of the models follow that kind of alternate bearing up and down, with the exception of ordinary least squares and moving average. And following the plot of that, I also wanted to, before I get into the error metrics, see the differences of the predictive outputs and the actual value. So this is a table of differences. What I mean by that is it's like the distance between the predictive value and the actual value for each year predicted. A green cell marks the forecast that was closest to the actual value, and a red cell is the one that performed the poorest. So as you can see, moving average did not do very, very well. Next, I looked at the performance metrics we talked about earlier. If judging by the error metrics solely, the auto-regressive moving average performed the best as it had the lowest errors, and the long short-term memory had the lowest bias of any of the methods tested. So this is, again, is a plot of the error metrics, and the graph may be a little bit misleading until you find the zero line. If you look at the zero line, the graph, or pardon me, the line that has this closest to zero for each of the error types listed in the x-axis is the best performing from a error metric point of view. So from that, you can see that the auto-regressive moving average, the light green, performed closest to zero, so therefore it performed the best. Whereas the pink, the long short-term memory, is almost right on zero for bias, so it was the model with the least bias. So a couple takeaways from the test is that alternate bearing cycle is a little bit difficult to predict the on and off year, especially when some of the models have almost a linear approach. I was surprised that the autoregressive moving average did so well. It was within 20% of real yields for 9 of the 10 years forecast. So that was pretty impressive. The machine learning approaches they performed well, but they were a little bit volatile. And I think this has to do with not having properly adjusted hyperparameters and just still being relatively new to those approaches. It would have been interesting to have more tests with some of the external weather data to see if that could make a better predictive model. And then obviously, knowing post 1990 as the production got increasingly volatile, I was impressed that they performed as well as they did. And of course, Python did admirably the whole time. So I don't want to beat that drum too loud, but it worked very, very well. Looking to the future, again, I said it'd be nice to look at some of the weather data and see if we can come with a more robust predictive model. Obviously, looking at state-of-the-art machine learning algorithms as they change daily would be useful looking to the future. If I could get more data to throw at it, regression loves information. That would have probably increased our accuracy with our predictive outputs. And then, looking at some other inputs like remote sensing to add another spatial component would be very useful as well. So just to wrap it up, the machine learning and traditional approaches were evaluated. They provide a reasonably accurate prediction, even though the sparse inputs with significant seasonality. Python worked well and can be used as a framework for future study. And again, Jupyter Notebook, which is a container for the Python model, is mobile, and I can pass along to other people as a template. So, questions?
So talk, Jason. Very good. Do we have questions for Jason? We can place those into the chat box. I guess I would start out. You have a use case here of the filbert. How much would you have to change your framework to apply this to another agronomic crop or another fruit crop? What are the kind of adaptations there or changes you'd have to make in your Jupyter framework?
That's a great question. I think in terms of just the inputs, if you could obtain historical production data in the form of yield per acre or some other industry standard, bushels, that type of thing, the approach would be almost seamless. It wouldn't be any different. You would just be performing your forecasting the same methodology, just using a different input data set.
Okay. Todd asks or states, very nice study. How might you approach some of the spatial qualities in production?
Well, one of the reasons why there wasn't a strong spatiotemporal component of this is I didn't have a way of knowing where the orchards were beyond Willamette Valley. If I had specific locations, I would have looked at, I would have probably leveraged some spatiotemporal information in the form of vegetative indices, soil types, some other factors that would have made the model a little bit more robust, but I had to treat it rather generically just because I did not have the specific locations other than their general region.
I apologize. I missed a question. Sean had asked what presentation program or theme did you use for your talk here today?
It is a open slides, Google Slides template. I can look it up. I don't remember.
Okay.
Yeah.
All right. And James indicates basically the same question I had asked. Panos says machine learning algorithms such as trees and boosted forests work much better when nonlinear and or nested relationships between predictors are expected. Do you have any expectations that your predictors behave this way?
That's a very good question. It was kind of a shotgun approach. So you see that the regressive methods, traditional methods, I tried to kind of meet the complex and the simple and get everything in between. From the machine learning side, not knowing precisely how the inputs would affect the model, I tried to use one like the boosted trees with the nested approach and long short-term recurrent neural network to kind of cover all the bases. And the teapot algorithm was kind of a hybridization of the two. And I don't remember exactly which algorithm it determined was the best fit. It's in my notebook. I could look it up, but I don't have it all offhand. I just was trying to have a well balanced survey of methods to try and get as close to optimal as possible without getting too far into the weeds. One of the issues that Dr. Marini and I had was just trying to stay focused. He didn't have that problem. I had that problem because you can quickly get carried away with some of the time series forecasting methods. And so, yeah, I was just trying to find kind of a good model for each and try and hit all the high spots. I hope that answers that question.
Okay, Jason, excellent talk. I hope you're thinking of ways to move this ahead, either with industry partners or with other crops. It's a really great framework. The Jupyter Notebook framework we're finding for other things is just a great framework to be able to package analysis and forecasting algorithms.
Yeah, I'm probably going to continue to use it within the pistachio industry. That's where I work. But one of the things I really appreciate about Jupyter Notebooks, and it's not confined to just Python, but also in Julia and R, the different programming languages, you can see the logic behind specific outputs. And that's very informative, I think, because we can black box everything and just say, well, trust me. Well, this allows other people to evaluate and to kind of verify that, yes, in fact, the outputs are logical and we see where you were going with your logic. And that's how I learn. I've tried to decompose a lot of different approaches, and seeing it has been very, very useful. And that's why again, I feel like I'm a bit of a Jupyter evangelist, but I think they work very, very well.
Very well. Okay, moving on to our final speaker for today, Jeff Kling. It comes to us from one of my favorite places, Laramie, Wyoming. Visited there a couple of times and really enjoy that neck of the woods. Jeff works in local government there and is going to share a desktop application that he's developed for the Environmental Health Department in Laramie County. Go ahead, Jeff.
Good morning. Good afternoon for some of us. Can everybody see my screen?
Yep.
Excellent. So yeah, welcome to my little corner of the world here. This used to be my office, and before that it used to be a morgue for the coroner, and yeah, that is a paper towel dispenser because they changed it into a little kitchenette before making it into my office. So I will be presenting a desktop application for Cheyenne and Laramie County Health Department. Transition. Okay. And first, I'd like to thank my advisor, Professor Panos. Thank you to the Geography Department, the MGIS program, Beth. Thank you very much for what you do. I'd like to also thank the Health Department and to Laramie County for giving me this opportunity to use this project as a capstone. And I'd also like to thank my family. I'm looking forward to getting to know them once this is completed. So a quick overview of the topics I'll be going over. The top 4 challenges and respective solutions, the solution itself, and a demonstration of the application in action. So the first problem we faced was data storage. And a little background of this problem is we were trying to look for a way to move health's permits from being in an Access database into a different format because ArcGIS Pro is doing away with their support for Microsoft Access databases. And it looks like Microsoft is also going to be sunsetting Access here in the future, I think like 2025. They'll probably still support it, but I think that'd be the last big release. So the major challenge, since it also created subsequent challenges in other areas of the problem, was moving from their Access database to a different format. The solution requirements needed to be user-friendly, responsive, could not use Access or Excel, couldn't cost anything, able to be spatially enabled, easily maintained, and also deal with related a many-to-one relationship for attachments. So another problem that we had was the complexity of editing data in other database formats. The other databases that we looked at really relied on creating a front-end application, something familiar to the health technicians that they could use. One solution was editing strictly in ArcGIS Pro. As you can see, Pro's pretty busy for technicians that primarily focus on other aspects, and having them walk through the steps of creating a point and adding attributes to that point. It's definitely something we want to address in the future so that they're able to do it. For now, I think we kind of looked at that as a means to develop something else that was easier for them to work with. So the solution, it required ease of creating and retrieving, updating, deleting that data. Needed to reduce the workflow and man hours, and had to have an inherent process to manage the attachments and the hyperlinks for the public to access their permits. So another problem was geocoding. With addresses, a lot of the permits may not be tied to an address. So moving the data set from another database and geocoding on the address, there's a lot of permits that were not being migrated over. The solution needed to be drastically streamlined with the location process, which is currently the bottleneck, as it took several people, couple steps, and creation of redundant data to actually perform and get that septic permit data into our enterprise geodatabase for the users to see. So permit application method system also needed to be completely reworked. Right now, it was a one-to-one relationship in the Access database, and any additional attachments or drawings had to be appended into that PDF and attached to that permit. This created some work, a lot of work for the technicians, as they'd have to print out all the papers and then rescan them in to get it attached. It's pretty interesting to see that first time. So the solution requirements need to create, name, and store, and retrieve multiple attachments, provide attachment hyperlinks for public access through a web map, manage a one-to-many relationship, and really reduce the man hours needed to create these attachments for the permit. So the solution was to create or maintain the data within the feature class of the enterprise geodatabase. And this was done through creating a related table to maintain the one-to-many relationship with attachments, and a geodatabase view for the web map applications. This application is built on .NET, C#, WPF and using the ArcGIS Pro SDK core host. The core host DL provides access to Pro's geoprocessing capabilities for the desktop applications. It provides a lot of the stuff that's available in Pro. So combining the core host application with the .NET environment and an ArcGIS JS API, we were able to create an application that allowed the technicians to manage their permits in the geodatabase. And this also kind of spawned off a couple other applications for a couple different departments within the county. So there's a little bit over 2,000 lines of code. So we could go ahead and get started on the line-by-line code review. No, I'm just kidding. We'll get to the good stuff. Start here, the demonstration for the application. So let me switch over to the application here. So this is the starting the septic permit application. Start on my other window. So the technicians will see this window here. And while I was developing this application, they also requested that we kind of incorporate a electronically submitted capability for the public to submit applications to the health department. So they don't have to fill out paper, turn that in, and the technicians type it all into the permit application part. So with COVID and social distancing and stuff like that, they needed that capability to submit applications electronically. So these applications here are submitted electronically, and it will populate this list, and the technician will be able to choose one here. I'll choose Nick, and it will open up into an applicant data window. And here the technician will be able to go through, proofread the application, see if it's okay, and then print the application. And they'll take this form, open up on the window too. Everything's opening up on my main window. So this will migrate the data into a Word document. And the technician will be able to print this off and take it to the inspection site. And that's when the landowner permit applicant will sign it, and they will scan it back in as a PDF. Go ahead and emulate that here. So once this is all complete and taken care of, they could go ahead and import this into form's not auto sizing like it normally does. So once that application is good, they'll able to import that data into the permit application portion of the application. And this works in the feature class in the Enterprise Geodatabase. And a couple features that I worked into this is geocoding the addresses. As they type it in, they'll hit tab and it will do a search, and it will populate the township range section size and the point geometry for that feature. So the technician can work through the different fields that comprise the permit application data. Some fields are set to only allow a certain number of characters. So once everything looks good, go ahead and insert that permit. And it will come back, say permit was created in database. Would you like to print it? And go ahead and say yes. And that will make a printable permit for the technician to print out and have the applicant sign once again and scan that in as a PDF. So I'll go ahead and emulate that, and it will automatically attach that permit number to the file name. So close that. So looking at the feature class in the geodatabase, we're looking at the septic feature class and the permit table, which is right there, and the septic permit attachment view that will be used for the web map. And I'll actually create that one-to-many join. Looking at the feature that we just added. Let me see. I have to. It's always fun demoing software stuff because it always works all the time. I have to do. So I'll bring it up in our catalog and see if that works. Going back to the application. Once the permit is submitted into the feature class, the technician will be able to add the attachment by going there and let's see where I save that in the templates here. Go ahead and open that up. And that will create that join of the scanned in permit into that feature in the feature class in the database. So let me open this up. That's thinking. So a couple other features in this application. If we could look at look up permits based off of permit number. I'll be able to update all of the information for that permit. They could look it up by address. And if there's more than one address in the as a result, it will open up a window that allow you to pick which one you want to work with. So now if they don't have an address or geocourse to go off of, they'll be able to double click on this field. And this will open up a web map inside of an emulated browser. And here they'll be able to zoom in, find the location, click on that, and then close the window, and it'll ask if they want to update the coordinates to that location. Go ahead, click yes, and it'll be populated right there. And from that, we're able to populate other data using a spatial intersection to populate the township range section subdivision. If it pulls, if there's any owner information with that, it'll pull that. So that's one way to get the lat long for the permit. So another requirement was to create reports, and to do that, the technicians could just select the date ranges and do a search. And I'll bring back how many permits were entered, how many commercial, the types of the permits that they're looking for. Let's see if we could do. There's the permit that we entered. And so the public, they'll be able to go to a publicly facing web map and look at, turn that data on, look at their permit information. Clicking on their permit. And they'll be able to look at their finalized permit and all the other attachments that we were able to create with this application. So believe that is it for the demonstration. Go ahead and open it up for questions.
Okay, thanks, Jeff. Looking over here into the chat area, Eric asks, are permit records able to be pulled up from the map? Apparently you showed that, that's correct, yeah. Adrian asks, could this application be applied to other permit types such as zoning changes, demolition permits, etc.?
Oh, yes, absolutely. It's just really working, it's treating the feature class as a pretty much a table in the database. So depending on what kind of fields or permits that you're tracking, it could be coded for that specific permit.
Jeff, I'd ask, so this is apparently something that many municipal departments are going to face as access is migrated away from. Have you considered putting together, or have you put together sort of a best practices approach to this, or an outline that you could share with other, I don't know, other municipalities in Wyoming or that type of thing?
I definitely think there's a need for it. And kind of working through this program, I've kind of ran into a couple issues that working, for example, working with the Postgres SQL database, I was trying to use MPG SQL package or NuGet package to query the database to make it quicker, because there's kind of a lag going through the ArcGIS connections. One thing I found though is that the object IDs in ArcGIS were not necessarily what the table had in Postgres. So I think there was a kind of tables in memory for that session that would be posted to the source table essentially. So creating a kind of workflow or best practices document, I think would be very helpful for these organizations that used Access for a very long time, but now they're faced with kind of having to move away from that, but still be able to perform the data entry and manipulation and stuff in a familiar format through a form type based application. So I'm pretty sure I'll be working on that here.
Very good. Are there other questions for Jeff? Okay. Well, we're at the end of our 3 talks. We have talks coming up, but I have misplaced my table of those, and I can't share with you when the next one is. I apologize for my disorganization. I don't know if Beth is still on, if she could share when our next.
I am. I'm pulling it up. It's next Tuesday. Starting Tuesday, November 24th from 12 until 2. So we have 6 presentations that day. And then on Tuesday, December 1st, we also have 6 presentations from 12 to 2.
Excellent. Thank you, Beth.
Yep.
As usual, Beth is organized and on it, and I deeply appreciate that. I want to thank all of our speakers today for their talks. We're really happy that you were able to use this venue to satisfy the 596B presentation requirement. We look forward to our future talks that Beth has just mentioned, and we just wish everyone over the next couple of weeks, and as we go into the holiday season, that you stay safe with the pandemic at the stage that it is in, and that you're still able to celebrate some realm of the holidays with friends and family. That's all for today, and we will see you next week, next Tuesday, for the next round of talks. Thanks very much.